Hello everyone, welcome back to our discussion on the topic matrix, and today we will be discussing the inverse of a 3 by 3 matrix. Before we go into matrix proper, we'll be revising and discussing some terms we'll be need in our calculation for matrix. Now the very first term is transpose. Now the transpose of a matrix is found by interchanging its rows into column. The transpose of a matrix is denoted by the letter T in the superscript of the matrix. Example: if A is the given matrix, then A raised to the power of T is the transpose of matrix A. Now for our very first example, find the transpose of the following matrix: A1, which is 1 2 3 4 5 6 7 8 9. Now A1 transpose, which means we are interchanging our row with our column. Our row, which is 1 2 3 4, become our first column, so it becomes 1 4 7 2 5 8 and 3 6 9. Now our second example, A2 equals to matrix 2 0 minus 1 3 5 4 6 1 7, and A2 transpose will be equals to interchanging our rows with our column. It becomes 2 3 4 0 5 1 minus 1 4 and 7, and finally A3 is equals to matrix minus 3 2 5 7 0 minus 6 4 minus 1 8, and when we transpose it to be equals to minus 3 7 4 2 0 minus 1 and 5 minus 6 8. So for transpose, we are basically just changing our rows to our column. The second term we will be discussing about is cofactor. Now a cofactor is a number obtained by eliminating the row and column of a particular element which is in the form of a square or rectangular matrix. Now the cofactor is preceded by a negative or positive sign based on the element position. Now based on the position, we are using a matrix to signify the sign. That's our first element to be plus, the second will be negative, plus, so on and so forth. So it goes plus minus plus minus plus minus plus minus plus. Now we have a very first example which says that find the cofactor of the matrix A, which is equals to matrix 1 4 7 2 5 8 3 6 9. Now writing that our new element, because our cofactor, we are interchanging each element with their smaller matrix and using the sign based on their position. So we get a cofactor which is A11, A12, A13 all the way to A33. Now for A11, which is our first element of our cofactor, we are eliminating the entire rows and the column that intersect with that element. So we are left with the smaller matrix 5 8 6 9. And when we simplify the smaller matrix, that is find the determinant of that matrix to be equals to 45 minus 48, which is equals to minus 3. Doing similar thing for A12 to be, we'll be left with 2 8 3 9 as our smaller matrix, and finding the determinant to be equals to 18 minus 24, which is equals to minus 6. Doing the same for A13, our smaller matrix will be 2 5 3 6, and find the determinant to be equals to 12 minus 15, which is equals to minus 3. And for A21, it will be equals to 4 7 6 9 as our smaller matrix, which is equals to 36 minus 42, which is equals to minus 6. For A22, eliminating our rows and our column, our smaller matrix will be matrix 1 7 3 9, which will be equals to 9 minus 21, which is equals to minus 12. And for matrix A23, which will be equals to 1 4 3 6, that's our smaller matrix, finding the determinant to be equals to 6 minus 12, which is equals to minus 6. For A31 to be equals to 4 7 5 8, that's our smaller matrix, and when we find the determinant to be equals to 32 minus 35, which is equals to minus 3. And for A32, our smaller matrix will be 1 2 7 and 8, and the determinant will be equals to 8 minus 14, which is equals to minus 6. For our final element A33 to be equals to 1 4 2 5, which will be equals to 5 minus 8, which is equals to minus 3. Now remember that for cofactor, there are positional signs, so it goes plus minus plus. So what we are going to be doing is that we're going to be multiplying each of our elements by their corresponding signs. So doing so, our cofactor will be equals to matrix plus a11 minus a12, and so on and so forth, which will make our cofactor to be equals to minus 3 6 minus 3 6 minus 12 6 minus 3 6 and minus 3. Now the last concept we'll be discussing is adjoint. The adjoint of a square matrix is the transpose of its cofactor matrix. That is, you just transpose the matrix you get from the cofactor. That will give you your adjoint of a square matrix. Now, after discussing the previous concept, we are going to be treating inverse of a 3 by 3 matrix. Now, the inverse of a 3 by 3 matrix is gotten using the formula inverse is equals to adjoint over determinant. Hence the reason why we discussed adjoint and determinants earlier. Now, for example, A inverse will be equals to the adjoint of A divided by the determinant of A. Now we have our very first question from NECO 2002. It states that if A is equals to matrix 1 0 1 2 1 3 4 2 1, find A the inverse of A, and B show that A times A inverse will be equals to I, where I is an identity matrix. Now for our solution, we know that A inverse is equals to the adjoint of A divided by the determinant of A. Now we are going to be solving this in step, and our step 1 will be to find the determinant of A, step 2 to find the cofactor of A, step 3 transpose of cofactor of A to get adjoint of A, and step 4 is to substitute this value and get our inverse. Now for our step 1, which is finding our determinant of A will be equals to, using our determinant formula, 1, our smaller matrix will be 1 3 2 1, minus 0, our smaller matrix will be 2 3 4 1, plus 1, and our smaller matrix will be 2 1 4 2. Find the determinant of the smaller matrix to be equals to 1 in bracket 1 minus 6 minus 0 in bracket 2 minus 12 plus 1 in bracket 4 minus 4, which simplifies to be equals to 1 in bracket minus 5 minus 0 in bracket minus 10 plus 1 in bracket 0, which will be equals to minus 5 plus 0, which is equals to minus 5. Now for our second step, which is the cofactor of our matrix A, using our cofactor elimination, we are going to be getting the smaller matrix. What we are going to be doing that we are going to be getting our smaller matrix and adding the sign at the same time for ease. So our first element becomes plus the smaller matrix 1 3 2 1. Our second element becomes minus the smaller matrix 2 3 4 1. The third element becomes plus the smaller matrix 2 1 4 2 minus the smaller matrix 0 1 2 1 plus the smaller matrix 1 1 4 1 minus the smaller matrix 1 0 4 2 plus the smaller matrix 0 1 1 3 minus the smaller matrix 1 1 2 3 plus the smaller matrix 1 0 2 1. So finding the determinants of all the smaller matrices, A cofactor will be equals to matrix 1 minus 6 for our first element, minus in bracket 2 minus 12 in bracket 4 minus 4 minus in bracket 0 minus 2 plus in bracket 1 minus 4 minus in bracket 2 minus 0 0 minus 1 in bracket minus in bracket 3 minus 2 and 1 minus 0 in bracket. Simplifying, A cofactor will be equals to matrix minus 5 10 0 2 minus 3 minus 2 0 minus 2 and 1. And for our step 3, which is the adjoint of A, that is, we are simply going to transpose A cofactors. So the adjoint of A will be equals to matrix minus 5 2 minus 1 10 minus 3 minus 1 0 minus 2 1. So for our final step, to get our inverse, we are going to be substituting for the adjoint of A and the determinant of A. So therefore our inverse will be equals to minus 1 over 5 the matrix minus 5 2 minus 1 10 minus 3 minus 1 0 minus 2 minus 1, which when simplified further will be equals to the matrix 1 minus 0.4 0.2 minus 2 0.6 0.2 0 0.4 and minus 0.2. For the second part of our question, which states that show that A multiplying A inverse will be equals to I, where I is the identity matrix, we are going to be multiplying A and A inverse, and when we do that, it becomes multiplying both of them in brackets 1 times 1 in bracket plus in bracket 0 times minus 2 plus in bracket 1 times 0 for our first element. Our second element will be in bracket 1 times 0 minus 0.4 rather plus 0 times 0.6 plus 1 times 0.4 all in bracket. Next element will be in bracket 1 times 0.2 plus in bracket 0 times 0.2 plus in bracket 1 times minus 0.2. Our next element will be in bracket also 2 times 1 in bracket plus in bracket 1 times minus 2 plus in bracket 3 times 0. Our next element will be 2 times 0.4 in bracket plus 1 times 0.6 in bracket plus 3 times 0.4 in bracket. Our next element will be 2 times 0.2 in bracket plus 1 times 0.2 plus 3 times minus 0.2. The next element will be 4 times 1 in bracket plus 2s minus 2 times minus 2 rather in bracket plus 1 times 0 in bracket. The next element will be 4 times minus 0.4 in bracket plus 2 times 0.6 in bracket plus 1 times 0.4 in bracket. And our final element will be 4 times 0.2 in bracket plus 2 times 0.2 in bracket plus 1 times 0.2 in bracket. Simplifying all our brackets, we get the matrix 1 0 0 0 1 0 0 0 1, which is our identity matrix for a 3 by 3 square matrix. We are going to be treating another question from NECO 2003. It states that A. Find the cofactor of matrix B is equal to matrix 5 6 1 7 8 1 minus 1 minus 15 and 8, and B. Hence find the inverse of matrix B. Now for our solution, our cofactors of B are eliminating the rows and column of each element and adding the corresponding sign. Our first element will be plus, our smaller matrix will be 8 1 minus 15 8. Our next element will be minus, our smaller matrix will be 7 1 minus 1 8. The next will be plus, our smaller matrix will be 7 8 minus 1 minus 15. The next element will be minus, our smaller matrix will be 6 1 minus 15 8. The next will be plus, our smaller matrix will be 5 1 minus 1 8. The next will be minus, smaller matrix 5 6 minus 1 minus 15. The next will be plus, smaller matrix 6 1 8 1. The next will be minus, smaller matrix 5 1 7 1. And our last element will be plus, our smaller matrix will be 5 6 7 8. Now find the determinant of our smaller matrix and put in our cofactor matrix. It will be equals to, our first element will be 64 minus in bracket minus 15, which is also in bracket, minus bracket 15 in bracket minus minus 1 in bracket in bracket minus 105 minus 8 in bracket. Our next element will be minus bracket in bracket 48 minus 15 in bracket, also bracket in 40 bracket minus in bracket minus 1. Our next element will be minus bracket in bracket minus 75 minus in bracket minus 6. The next element will be bracket 6 minus 3, which are both in bracket, minus in bracket 5 in bracket minus 7 in bracket. Then our last element will be bracket 40 in bracket minus 42 in bracket. And simplifying our brackets to be equals to matrix 79 minus 57 minus 97 minus 63 41 67 minus 22 and minus 2. And for the second part of our question, that's the B part, we are asked to find the inverse of matrix B. Now we know that the inverse is equal to the adjunct of B divided by the determinant of B. So first we'll be finding the determinant of B, and doing so, determinant of B will be equal to 5 smaller matrix 8 1 minus 15 8 minus 6 smaller matrix 7 1 minus 1 8 plus 1 smaller matrix 7 8 minus 1 minus 15. Finding the determinant of each of our smaller matrix to be equal to 5 in bracket 64 minus in bracket minus 15 minus 6 in bracket 56 minus in bracket minus 1 plus 1 in bracket minus 105 in bracket minus 8. Expanding our bracket to be equal to 395 minus 342 minus 97, which is equals to minus 44. Now our next step, we are going to be finding the adjoint of B, which is the transpose of B cofactors. Now our cofactors of B is equals to matrix 79 minus 57 minus 97 minus 63 41 69 minus 2 2 minus 2. And when we look for our addition, that is, so we transposing it to be equals to 79 minus 63 minus 2 minus 57 41 2 minus 97 69 minus 2. Now to get our b inverse, which is equals to the adjunct over determinant, to be equals to 1 over 44 matrix 79 minus 63 minus 2 minus 57 41 2 minus 97 69 minus 2. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copies in bookshop, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.